Welcome to Advanced Java Programming at Portland State University. In this screencast, we'll discuss the dependency injection design pattern that allows you to develop code and scale it, keep it decoupled and testable. So the whole idea behind dependency injection is that it decouples dependent objects. You've got one object that needs another, and the dependency injection allows you to keep them separate so they can be configured and tested independently. In addition to the dependency injection design pattern, there is a library called Google Juice, which allows you to manage dependencies among objects and handles all the complexity of wiring all these objects together for you. So we're going to talk about three things in this screencast. First, we'll get an introduction to the design pattern itself, learn all about what dependency injection is. Then we'll see how objects that are implemented using the dependency injection design pattern can be easily tested with what are called mock objects using a library called Mockito. And finally, we'll look at using Google Juice to manage dependencies among objects. Okay, as a motivating example, let's consider the following set of dependent objects. You've got a bookstore, and a bookstore can do things like purchase a bunch of books using a credit card, or can refund a bunch of books using a credit card. Now, this then requires two other objects. It requires something that's a book inventory. Let's say there's a book inventory interface that the bookstore has. In book inventories, you can add books, remove books. You can ask whether or not, or how many numbers of books are in stock. And let's say that book inventory is implemented by a book database. Let's say everything is stored in a file in that book database. The bookstore also needs to be able to work with credit cards. And so let's say there's some interface that abstracts out the credit card service. And you can debit and credit a credit card for so much money. And let's say there is an implementation of that credit card service called the First Bank of Portland State University, which is really just a wrapper around a REST service. And so maybe, First Bank of PSU has some servlet out there that's implemented at the other end of some web service that you call via REST. But all that's hidden behind this credit card service interface. So you've got all these objects and stuff like that. Now notice we've already taken care to abstract the interface out from the implementations, right? We learned that pretty early on. You want to program to the interface, only depend on as much of an abstraction is necessary. And why do we want to do this? Well, so that we can move to other implementations of book inventory or credit card service without having to change the bookstore implementation, right? So we don't want the purchase method to have to do something different. Okay, so how can we go off and implement Bookstore? Well, here would be one way of implementing Bookstore. Now, Bookstore has a book inventory and a credit card service, so we'll model those as fields, and they're not going to change over the lifetime of the Bookstore, so we'll make them final. And then when we construct our Bookstore, well, we'll need to construct our book inventory and our credit card service. Now, our Bookstore will go off and figure out where the book inventory is stored. Maybe it's off in a book file called books.txt, off in some temp directory someplace. And we'll also create a credit card service, our new First Bank of PSU, and just for testing purposes, let's say it's running on localhost port 8080. So in this model, when Bookstore is created, it also creates its dependencies, the objects that it needs to get its work done. What does our purchase method look like? Well, purchase method just uses those two fields that we initialize in our constructor. When we go to buy a bunch of books and charge it to a given credit card, we go and iterate over the list of books, remove it from the inventory, and total up the price. Then once we have the total amount of the transaction, we'll go call the debit method, and if it returns success, then that's great. Otherwise, we'll throw an exception. So notice here the purchase method uses the dependencies. Okay, so you can implement it this way, you can run it, and it'll all work, but you can't test this code. Right? This code requires that you have an actual credit card service running. So every time you want to run a test, you want to test the logic of your purchase method, you'll have to make a credit card transaction. And it'll also have to go off and have its own book inventory database, and that can be slow. Also, you'll have to set up lots of data, right? Create the database file itself, create the credit card account, and everything like that. Additionally, the bookstore needs to know how to configure its dependencies. Right? The bookstore itself wants to program to the interface, but yet the constructor needs to know that the bank that you're dealing with is the First Bank of PSU, and that the bookstore, the book inventory implementation requires this temp file. Does the bookstore really need to know that? Is that a good thing? Also, if you wanted to have another class that uses that same book database, right? Maybe the thing that controls your inventory, it would have to create another instance of that book database, or your bookstore would have to expose the fact that it's got the book database, and then that other application. So let's say it's a thing that like updates the inventory when a new shipment of books comes in. All of that would have to know, and all of a sudden things start getting really coupled. And finally, if you want to switch out another implementation of the dependency, so you want to use a different implementation of credit card service or a different implementation of Bookstore, maybe the one that writes to a relational database or stores this information in the cloud or something like that, you'd have to change the Bookstore itself. So if you go into the Bookstore code just to change the implementation. So again, it sort of really begs the question, does the Bookstore really need to know what kind of book inventory it uses? Or it just has to know that, hey, there is a book inventory and I'm going to use it? Well, these are the kinds of questions and issues that are addressed by the dependency injection or dependency inversion design pattern. There's something called the Hollywood principle, which is basically, don't call us, we'll call you. It's hard to say that without sounding cheesy. Of course, then again, it's hard for me to say anything without sounding cheesy. It's just the way my voice sounds. A Hollywood principle states that dependent code should require that its dependencies be provided to it. So it shouldn't create the object it depends on. Instead, the object it depends on should be provided to it. And what does this mean in practical terms? Well, the constructor should take all of the dependent objects that it needs. So following the Hollywood principle, our bookstore should have a constructor that takes two parameters instead, the book inventory and the credit card service, and all it does is store it away in the private fields, right? It doesn't have to create new ones or anything like that. Okay, so this is nice. The bookstore is now decoupled from its dependent objects, from the implementation of its dependent objects. And so now it's up to the main program to basically go through and create and configure the dependencies. So now all that logic that used to be inside the constructor of bookstore, well, now needs to be done someplace else, like in your main method. So now the main method goes and sets up the book database and the first bank of PSU, and then creates the bookstore from that. Notice that the implementation of the purchase method stays exactly the same, right? Because it programmed to the interface. It was just using those fields. So what we're really doing here is not changing the logic of our program. We are just changing the way that dependencies are specified. Okay, so now that we have a bookstore that has its dependencies passed to it, you can test it more easily without using the production book inventory and credit card services, right? So it just takes these two interfaces. And so you don't have to, in a test, you don't have to provide the full implementation or an implementation that goes off to a web service or something. You just need to provide the bookstore class, an instance of the bookstore class, an object that behaves like a credit card service should. So instead of using real dependencies, you can test with mock objects that provide an implementation of the interface that is useful for testing. So basically it provides everything, these mock objects implement the interface, so they behave, they provide the same contract, or at least the contract that's needed by the consumer of the mock object. But they don't actually do everything that the real implementation would do. So I put together a little class hierarchy. At the root is mock object, and it has a should not invoke method. One of the things about mock objects is that you're using a mock object, you're providing it to some class that's under test, and if the class under test does something that you didn't expect, you want to blow up. Right? It's a unit test that you're writing here. You want to make sure that all your code, your application, is behaving as you expected. So I have this mock object that basically has this one method which is like, hey, when you call me, something's messed up. And now I'll create a subclass of that mock object called mock book inventory and have it implement the book inventory interface. Right? This is the book inventory that is provided to the bookstore. I'll just say, hey, the implementation of the remove method on book inventory should not invoke. And then so now I've got this mock, and did I make that abstract? I probably should have made that abstract because the whole idea is that you wouldn't necessarily instantiate this guy directly. What you do in your unit test is use an anonymous subclass to provide the information that you want. So here I have a unit test that tests that, okay, when I purchase a book, it's removed from the database inventory, right? I purchase a book, it's removed from the book inventory. So first I need to set up a couple of mock objects that I'll then send to my code under test, my object under test. What I want to do is I want to have a book inventory that remembers which book was removed from it, right? I'm expecting that my bookstore is going to remove a book from my book inventory. So how do I do that? Well, it's kind of awkward because of the awkwardness of of anonymous inner classes, but here I have my book inventory, which is a mock book inventory, and I'm going to override the remove method to do something relevant for this test, which is basically take the book that was removed and store it off in this variable here, and because it's an anonymous inner class, I have to have something that's final, so I can't just write the value of this off to a final field. Instead, I have to use this dumb little trick where I have an array of books of size 1, and I'll store it into that. Don't worry, I'll get better later. Now, I also need to pass a card service to my credit card service to my object under test. And what I'll do here, I didn't show the code, but I've got a mock credit card service, which is just like that mock book inventory. And here I'm going to override the debit method to basically say, hey, up, any transaction you try to make is going to be a success. Here in this test, I don't really care what the credit card service does. As a matter of fact, I just want the credit card service to just let me do it, because what I'm testing is whether or not the remove method on the book inventory is called correctly. Okay, so now I've got these two mock objects that provide behavior that I want for my test. Now, I'm not testing the book inventory and the credit card service itself, and what I'm really testing is the bookstore. So now I've got the mock objects set up. Those are the dependencies. I'll use those guys to create the bookstore. And I do that here. I say, okay, I'll create my bookstore with my mock inventory and my mock credit card service. And then ultimately what I want to do is I want to call purchase. And so to call purchase, I need to have a book, books and a credit card. So here I create my credit card. I'm going to have a book. Here again, I don't care what the credit card number is. I don't, I kind of do care about the book, and then I'll compare it against what was sent to the book inventory later. But the actual information isn't terribly important. What is important is that I evoke the method that I want to test, which is purchase. So I'll call this on store. I'll call purchase. And I've got to send in, well, it's a collection of books, so I'll send in a singleton list containing my test book and my credit card. And I'll assert that the total that was returned by the purchase is equal just to the price of the book. And this is how much I tolerate. I won't tolerate any difference. And that's really what I'm testing here. Well, I guess I'm testing two things. First of all, I'm testing that, yes, it sort of went through all of the logic of the purchase method, meaning when I purchase one book, the total is just what is the price of that book. And then I also want to test that my book got sent to the remove method of my book inventory implementation. Remember, my book inventory is one of these mock objects. And what the implementation of remove does, well, it socks away the book that was sent into this variable right here. So here I'm going to assert, first of all, I'm going to get the book that was removed, okay? I'm going to say, hey, was it not null? Okay, good, so something was there. And then I'm going to make sure that the title, author, and price of my removed book are the same as my test book. Actually, I could probably, knowing my logic, I could even say, hey, I could just use assert equals on the two books. But this way, maybe somewhere in the guts here an object is cloned, or it's written to the database and read back, or whatever. Hey, I really don't care. What's important in this test is that the title, author, and price are all the same. So that's what it's like to work with mock objects. You set up your dependencies, your dependent objects as mocks, meaning they're the real implementation. They're something that provide the behavior that you're interested in for the unit test. Then you'll create the object that you want to test, the object under test, in this case the bookstore. You will, perform the operation that you want to test and then verify that the dependency was invoked the way you expected it. These kind of mock objects get the job done, but as you can tell, it's a little awkward, right? You had to have this little class hierarchy of mock objects, and then you have sort of the problem of anonymous inner classes that you can't save off the values very easily, blah, 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 and it results in a lot of boilerplate code, so that's not that interesting. Also, because you have actual implementations of interfaces, when you change the interface, you add a new method, you change the signature, whatever, the mock has to change. And so keeping everything up is kind of a pain. And let's face it, having to subclass a mock object for every test, it's kind of hokey. You end up with a lot of anonymous inner classes, and just a lot of code to look at, lots of lines of code. That silly trick of like keeping track of what state was passed. And so this is like a good pattern. It lets you test, but there's got to be some better way. Well, and there is. There are a number of testing libraries out there implemented in Java, and there are ones for other languages too, that are for creating mock objects that work more easily than this example that we just saw. The one that I like right now, and the one that we're going to discuss in this class, is called Mockito. I think it's supposed to be like Mojito, but Mockito. Basically what it does is it uses some fancy reflection and other things like that to provide a Java API to create mock objects for interfaces and classes. So instead of having to write your own implementation of your interface to mock out, you use the Mockito API. The API embodies what's called a DSL, a domain-specific language for constructing mock objects. And actually, it takes some getting used to, and the syntax is a little weird, and if you start digging into the implementation, it takes a while to really understand what's going on. So you can approach this in either one of two ways. You can sort of look at the examples and sort of take that leap of faith that everything is happening and we'll do the right thing, or you can really dig into the implementation and understand all the kind of crazy stuff they're doing, which I think is kind of fun. We won't go into that much detail here, and really get a deep understanding of what Mockito is giving you. But the whole idea is that you can use this series of method calls to specify what behavior you expect out of the mock object. So instead of implementing your own methods, you use this little DSL implemented by the Mockito API. So Mockito can be added to dependency of your Maven project using something like this right here. Let's walk through an example of using Mockito. We're going to do that same thing that we did in the previous example. We'll walk through the code, and then we'll go back and look at some of the details. No, actually, well, we're not going to do exactly the same thing. So instead of testing that the book was removed from the inventory, we're going to test that the credit card was charged the amount that I expected. Actually, let's just skip down here in the end. Right here, this code, starting when we create the bookstore, look pretty familiar, right? We create a bookstore with the inventory and the card service. We'll ignore that for right now. But then we make the purchase on the card, and we assert that the price equals what we expected. So really, when it comes to the code under test, well, it's just the same as it was before. But what we see that is different is the way that you set up your mock objects. The Mockito API provides static methods that, like this mock method, which creates a mock instance of something, of a class of an interface. And so you say, hey, give me a mock instance of book.class. And I don't care what the title of the book is, I don't care what the author, description, whatever that other field is, but I do care what the price is. And so what I can do with the Mockito API is say, okay, when book.getPrice is invoked, then return price, which is this variable right here. So these are all Java method calls. There's no crazy language stuff going on here. What we're just doing is we're calling a very interesting API. So when book.price is invoked, then return price. So essentially what this does is it says, hey, mock object, well, when your getPrice method is invoked, return the value price. I'll create a book inventory, a mock book inventory. I'll create a mock credit card service. And I'll say the following. Okay, when the debit method of credit card service is called with any credit card instance and any double value, then return success. So this is doing the same thing that we had in our implementation of the mock object, which is saying, hey, listen, anytime debit is called, yeah, it's successful. Don't worry about it. Wish I had a credit card like that. Har har. Okay, fine. So it's basically specifying the behavior of our mock object using, well, these kind of interesting method calls. Okay, so I've created my mock book inventory, my mock credit card service, and now let's create my real object. Okay, now I'm creating real objects. I'm calling new instead of mock. So I'll say, okay, great, create me a new bookstore with that inventory and that credit card service. And oh yeah, by the way, I need a credit card. Yeah, make me a mock one of those too. I don't really care what that credit card is. And now I'll invoke my my method under test. So I'll say, okay, purchase, so store.purchase, my book that I care about, it's a mock book, using the credit card that I care about, it's a mock credit card, and then assert that yes, the price of the book was what I expected. Well, the total is the price of the book with 0 deviation. So that's like the same old stuff I would expect before. But then finally, I want to say, I want to verify the following. I want to verify that yes, the bookstore implementation, when I called purchase, indeed invokes the debit method of my card service with the card and price that I expected. And the way I do that using Mockito is I say that verify card services, verify card service dot debit card price. This is a little wacky because it looks like we're calling the method here. We're not really doing that. What the verify method in Mockito does is it creates like this special, well, I'll talk more about what it means in a minute. So anyway, this is a lot to get to wrap your head around. Let's go into some detail and take a closer look. Okay, if you go and look at the API docs, the most interesting methods of the Mockito API are in the Mockito class. And it has a whole bunch of static methods that create mock objects for an interface or a class. So for instance, there is a class mock. And here's what the signature looks like. Okay, it's a static method, and there is a type variable t, and it's the mock method, and it returns something of type t, and it takes as an argument a class of type t. So here we go. This is that generic stuff again. We're going to say, hey, pass in a class of a certain type and return something of that type. And sure enough, when we look at the mock method, we send in book.class and we get back a book. That's basically what all of this means. So when you call mock, what this returns you is an instance, an object that implements the interface or extends the class that you passed in. Unless you tell it otherwise, invoking any method on that mock object will either do nothing if it's a void method, or will return null, or the equivalent of null, like a 0 value if it's a primitive, or return null. So this is basically saying, hey, create me a mock object that does nothing. If you go and look at the implementation, I don't want to go into the implementation now, it does some really neat class loading tricks, some neat things with dynamic proxies to get all of this to work. I think it's very clever. I think it's kind of a fun thing to look into. Now, note that we mocked all of our objects in the previous example, or all the dependent objects. We didn't mock the actual object under test, right? We called new bookstore, but everything else here was a mock. This means that we didn't need to invoke any constructors. Underneath the covers, it's possible that some constructors will be invoked, but most of these things were interfaces, right? There are no constructors on interfaces. It's just like, hey, go off and create me some object that implements that interface. And notice we only had to specify the state that we needed. Here again, the book instance that we created, we just specified what the price should be. We don't care what the author or the title of the book is. And by only specifying the functionality that you need, and because this deals with not direct implementations of interfaces, but only sort of like using this magical reflection stuff, we can add a method to an interface or change a signature without having to update a mock implementation. So I can add another method to, let's say, the credit card service, and unless, and this test, which was like pre-existing, wouldn't care. You wouldn't have to go back and change any of this code just to accommodate that new method. Okay, so that's the mock method, which creates a new instance. There's also a method called when. And what when does is it specifies how a method of the mock should behave. Right? So let's go back to our example. When book.getPrice is invoked, then return the price. Okay, what does this look like from the API? The when method takes something of type t and returns an object that is called the ongoing stubbing of type t. Ongoing stubbing, I don't really know why it's called that, but what it allows you to do then is then call the methods like then return some value. So like we saw, when book.getPrice is invoked, then return our price. You can also specify other methods on the ongoing stubbing object that you get when you invoke when. You can say then throw. So maybe we want to have an implementation of the credit card service that always throws like network connection error or something like that. Okay, you can mock it out. You can mock out the credit card service, and then you say, hey, when a debit is invoked, then throw cannot connect to server exception, something like that. If you have a mock that's wrapped around a real object, which we did in the case of book, you can say, hey, then call the real method, so the real implementation of it. This is when you want to mock some behavior of the object, but then have other behavior of the object just do the thing that it does before. I don't know if I've really ever had the call to use this method, but it's available. The sort of the pattern that you get here is statements like this. So when book.getPrice, then return price. This is what is meant by a domain-specific language. This kind of looks readable, right? All you're doing is calling these methods, but between the names of the methods and how everything can be chained together, you get something that looks more readable than saying, hey, when this and storing off into a value of ongoing stubbing, then return. This seems a little easier to read. You can use what are called argument matchers to specify, well, multiple kinds of behavior for a given method. So for instance here, I want to say, well, when the debit method of my credit card service is invoked with the card and price that I expect, return success. But I can also say for that same card service, well, when debit is invoked with the card that I expect but a value of -1, then return invalid amount. Right, so what I can do here is by using different matching, so either the price that I expect or a value like -1, I can return different behavior. So I can have my mock method have a good amount of logic in it. Now, sometimes the behavior of the mock, it doesn't matter what the actual value is. You just want to say, hey, listen, no matter what I invoke it with, do this thing. So like always return success, no matter which card is passed in. And there is this matchers class, which is available through Mockito, that has these these methods that you can call to match different kinds of values. It's actually very reminiscent of the Hamcrest matchers that we've seen in unit testing. So there are a bunch of any methods. So you can have any object or null or any object of a given class, any int, any double, any string. And then you can say, hey, as long as the value isn't null, go ahead and return success. Or hey, if it's if it is null, return failure. If it's not null, return success. If it is the same, which is sort of like what we have here. If it matches some regular expression, stuff like that. I think we have an example of it. Yeah, right here. So like when the credit card service, the debit method of the credit card service is invoked with any instance of credit card and any double, then return success. So here we use the any matchers on the credit card service. A little side note here, something that I had to learn the hard way. When using the matchers, if at least one of the arguments to the mock method is a matcher, then you must use, then all of the arguments must be matchers, meaning that you must say something like, when the debit method of credit card service is invoked with any credit card class and a value equal to -1, then return invalid amount. You can go look at the Mockito API. It's actually very rich. It's all sorts of really cool matchers and things like that, including these additional matchers, which will let you put together very complex, well, not very complex, more complex, let's say, logic around matching. So you can have Boolean operations. You can have greater than, less than, equal to, greater than, equal to, all sorts of good stuff like that. Finally, the final thing that you do with mock objects is that you verify them. So, right, you can specify the behavior of the mock objects using when, and then after you've run your test, after you've exercised your object under test, which has presumably interacted with your mock objects, you can verify that the object under test interacted with the mock object in the way that you expected. And this is part of your test. And so this is what the verify does. After you've configured your mock objects and use them to run your test, you can verify your mock objects that they were invoked the way that you expected. And the way this works is that the Mockito mock object will maintain a history of what methods were invoked and which arguments they were invoked with. It's kind of like, well, keeping a little list of, okay, this method was invoked with these values, and then it was invoked with this value here, and you can play that back and verify it as part of your tests. And the way you do that is with the verify method. So here is an example from our unit test. We're going to verify. So after we've called deposit on our bookstore, we're going to verify that the debit method of card service was invoked with the value of card and price that I expected. And you can also use matchers, the same matchers that you use with when. You can also use them with verify. So this line here is the same as saying verify that the debit method of card service was invoked with, well, the same card that I've got before and an equal price. Okay, I think we've reached a good stopping point for right now. So we've seen what the dependency injection design pattern is all about. Essentially what you're doing is instead of having objects create dependent objects are provided to them. And the way this takes shape is usually instead of the constructor of an object creating other dependent objects, the dependent objects are provided to that constructor. So more constructor arguments. And what this dependency injection pattern allows you to do is then test those objects using mock objects, objects that provide the same functionality, or maybe the subset of the functionality that the code under test needs, but doesn't require you to actually create, the real implementation of it. So instead of having to, connect to a database or call off a REST service, you just have an object that behaves like it did, because you're not testing the object that calls the REST service. You're testing the object that uses the object that calls the REST service. And then we ended with a discussion of the Mockito API for creating mock objects using a DSL, which is much more compact and much more powerful than probably what you could write yourself. Okay, so as always, thanks for watching the screencast for Advanced Java Programming at Portland State University.